Let's look at solving systems of linear inequalities. So for example, here we have a system of linear inequalities with two inequalities. 2x minus 3y is less than or equal to 12, and 3x plus 2y is less than 8. So our first step, we're going to solve the first inequality for y. That means get y by itself. So I've got 2x minus 3y is less than or equal to 12. To get y by itself, let's first subtract 2x from both sides. And we're left with negative 3y is less than or equal to negative 2x plus 12. Now we'll divide everything by negative 3. And we end up with y is greater than or equal to 2/3 x minus 4. Notice, because we divided both sides of an inequality by a negative number, we needed to flip the inequality symbol. Step 2, let's graph the inequality. So our inequality again was y is greater than or equal to 2/3 x minus 4. We've got a greater than or equal to symbol, so that means we're going to have a solid line because of the equal bar. We would also have a solid line if it were a less than or equal to symbol. So the y-intercept for our inequality is negative 4, and the slope is 2/3. So if I've got a coordinate plane where every grid line is representing one unit, I'm going to put a point at our y-intercept at negative 4 and use our slope to rise 2 and run 3 to get a second point. And I could do a few more to help me draw a straight line. And then I'll draw a solid line through those points. Step 3, let's shade the region on the side of the inequality line that satisfies the inequality. So our inequality was y is greater than or equal to 2/3 x minus 4. It's greater than or equal to, so we want to shade above the line. So I'm shading above the line. Now, if it's not clear what is above, you could choose a point. And we want to choose a point that is not on the line. So I could choose the point 0, 0, the origin. So here we're going to take our inequality. I'm putting it back in standard form, but we could have left it in the form that we had above. So 2x minus 3y is less than or equal to 12. 0 is my x value. 0 is also my y value. Let's substitute in. So 2 times 0 minus 3 times 0. Is that less than or equal to 12? So that's a less than or equal to symbol with a question mark above it. We're asking, is this inequality true? So simplifying, 0 minus 0 is, we're checking, is that less than or equal to 12? Well, 0 is less than or equal to 12, so yes, this is true, yes. So we have satisfied our inequality. So because that point satisfies the inequality, we would shade the side of the line that includes that point. If the inequality was not satisfied, we would shade the opposite side of the line, so the side of the line that does not include that point. Okay, now we'll repeat the steps, those first 3, for the second inequality. And if we had a third or fourth inequality, we would continue to do it for those as well. So step 4, solve the inequality for y. So this time our second inequality is 3x plus 2y is less than 8. So getting y by itself, let's subtract 3x from both sides. We're left with 2y is less than negative 3x plus 8. Let's divide everything by 2. And I have y is less than negative 3/2 x plus 4. Okay, then we will graph the inequality. So remember, our inequality is y is less than negative 3/2 x plus 4. The y-intercept is 4. The slope is negative 3/2. Let's bring back our graph from before. And now we'll put a point. Well, first, our inequality symbol is less than, So it's going to be a dotted or dashed line that we draw. So I'll put a point at my y-intercept at positive 4 and use my slope to go down 3 and right 2 and plot a few points and then draw in my dashed line. Step 6, shade the region that satisfies the inequality. So here we have a less than symbol, so we want to shade below the line. That's down here. And finally, our solution will be where all the shading overlaps for all the inequalities. So for us, that is in this sector over here. And ours is unbounded, so it does keep going in the up and left direction forever. There are times when we have a bounded section where it's bound off by another line, whether solid or dashed or dotted. But here is our solution.